Hi everyone, and welcome to the first lesson for Contest Stream. So today we will be going over functions. So what is a function? A function basically encompasses or says that for every input, there exists only one output. So you can kind of think of this as a machine, right? So for every x, there only exists one y. And how can we really check this? Well, we can check this by doing something called the vertical line test. So I will just annotate here. So if we have a function, let's let this be the x-axis and this be the y-axis. So the vertical line test is basically when I can just draw a line. Well, I'll draw my function first. So if I have a function like this, it looks like a parabola. And if I do a vertical line check, so I draw any vertical line anywhere on the screen, you can see that it only passes through one point. And I can do this like at anywhere on this thing, as long as it is parallel to the y-axis. You can see that there only exists one point of intersection. But however, if I have, for example, another parabola, I will just draw one. If I have something like this is not a function because if I were to do the vertical line test, like let's say here, if there exists one point where for one x value, let's say x equals 3 here, that there are two y values, then that is not a function because we said a function is something that for every input, there only exists one output. And we can check this through the vertical line test, as we said, or we can check this through contradiction. So maybe we have like y squared equals x. So if y is, for example, -3, -3 squared equals 9, right? But also 3 squared equals 9. So we have two values of y for the same value of x, so that doesn't work. So that's another way we could check. Now moving on. So basically, yes, for every input, there is only one output. So for example, if you had f of x equals 3x plus 7, you would have f of 1 is 3 times 1 plus 7, which is 10. F of 2 is 3 times 2 plus 7, which is 13, and you can just keep going down the pattern. What you do is you basically substitute x here for everything inside the bracket. Okay, so I hope you've had enough time for that. If not, that's fine as well. So what we do here is basically we replace every x with 4x. So here we know that if f of x is 2x squared minus 3x plus 1, we can just put the 4x into each of these x's because that's what our input is. It's 4 times what x is. So we would just do 2 times 4x squared minus 3 times 4x plus 1. And then if we continued simplifying, we would get that because 4 squared is 16 and 3 times 4 is 12, we can just simplify and we get that f of 4x is 32x squared minus 12x plus 1. So I hope that makes sense. That is just a small warm up to get you guys started. So moving on, we're going to be talking mostly about special functions. So these are things that you might not have learned in school because they don't really teach you how to solve problems with these. They might mention it, but for contests, there's a lot of these functions that we aren't actually taught in school. So I kind of wanted to go over them. So you might have seen the absolute function. So basically it takes an input and it'll return a positive output for every input. So essentially, you can also use this for distance if you want the distance of something because the distance can't be negative. So for example, you can think that the absolute value of -4 is 4 because you can just think of this function as removing the negative value. So if I annotate here, we have, if we do like f of -3, we would get 3 because the absolute function, it always returns a positive output. And similarly, if we have a positive value, so I don't know, f of 11, what we get back is still 11 because it's already positive. So we don't really need to do anything to change it. All right. So for our first example, I'm gonna go through this one with you guys. So what if we have the absolute value of x squared minus 3x equals 4? Like, how do we go about solving this? It's not exactly like you can't just move the 4 to the other side because this is a little different. So what we have here is we know that because of our previous definition, it takes an input and returns a positive output. Here, we know that whatever's inside here, it can be 4, yes, but it can also be -4 because the absolute value of -4 is equal to 4. So here, this is where we actually have two cases. So the first case is where inside here, it's 4. So if it's 4, then we can just move the 4 to the other side. We subtract 4 from both sides, and then we can just factor it. I think you guys know how to factor, so that's fine. So if we factor it, we can just get our solution. So we know that x is -1 and x is 4. And on the other side, this is when the absolute value inside of it, it's negative. So that means that x squared minus 3x is actually equal to -4. So we would just do the same thing. I'm not actually going to factor it because like it gets a little messy, but if you just use quadratic equation, you can probably figure out the answer, and you also get two solutions as well. So now that you've seen that example, we're gonna go through a fun question, but this is the one that you guys are gonna do. So based on that example, we know that there are 4 solutions because when we factor this side, we got 2, and if you use quadratic equation, I was kind of lazy, so you would also get 2 here. So how many solutions are there to this equation and how can I find it? So I just want you guys to try this. I will give you 5 minutes. All right, I hope you guys had enough time for that question. If not, you don't have to listen to the answer, but I'll just briefly go over it. So first of all, we have our first one. So we assume that whatever is in this is positive. So we're going to say that x squared minus 6x equals 9. And like the one before, we also have our negative answer because what if the absolute value of -9, it's also actually just 9. So we have these two different formulas. We have 9 and -9. So if we go to solve this one, we're going to end up with x squared minus 6x minus 9 equals 0. So be careful here because this is actually not a perfect square trinomial. You actually have to use the quadratic formula to solve it. It's actually just 3 plus or minus 3 square root 3. And because of the plus or minus, you know that it has two solutions because it can be 3 plus square root 3, 3 plus 3 square root 3, or 3 minus 3 square root 3. Now the second one, if we move it to one side, we have x squared minus 6x plus 9 equals 0. And if we factor this, we actually realize that this is just it's just x minus 3 squared. So because of this, we know that here x can only be 3 because the solution to this is actually just the same one. It's x equals 3 twice. So because of this, So because of this, we actually only have 3 solutions, unlike the previous one where we had 4, just because in this one, x is 3 twice, and we only count one of them because that's how functions work. Okay, so I hope that made sense, and we will be moving on to the next one. So I can go over this one with you guys, just briefly. So this might be another type of question you might see. So solve for all real values of y such that the absolute value of 3y plus 7 equals the absolute value of 2y minus 1. Now you might think, wow, this is actually really complicated because that means this side, the left side, can be positive or negative, and the right side can also be positive or negative. But actually, if we think about this a little more, we either have this, so either both of them are positive or both of them are negative. So if both of them are negative, so we would have, okay, let me annotate. We would have negative 3y plus 7 equals negative 2y minus 1. But actually, because we have this, we also notice that because they're both negative, the negatives just cancel, right? Because negative 1 divided by negative 1 is just 1. So we can actually just ignore these negatives. And then our other case would be if they're both positive. So notice that if they're both negative, if they're both positive, or if they're both negative, you actually just get the same equation. So that's pretty cool. And if we solve this equation, we move the 2y here and we move the 7 over here, we get y equals negative 8. So that is one real value of y. And then conversely, we have this. So we have 3y plus 7 equals negative 2y minus 1. And you might be asking me, Star, hey, why isn't the 3y plus 7 a negative? Because obviously we said we have to do it to both sides, but the reason is quite similar to the first one. So if we do the same thing as before, if we put the negative on the 3y minus 7, 3y plus 7 equals 2y minus 1, these are actually just the same thing, because I can just put the negative, like I can divide by negative 1 on both sides. And I can just move this thing over here. So you would get the same solutions for these. So it actually doesn't matter which one you choose. And as you may notice, we technically have 4 different equations, but they reduce to 2 simple equations. So if we continue to solve this, we have 3y plus 7 equals negative 2y plus 1. And if we solve and simplify, we get 5y equals negative 6 and y equals negative 6 over 5. And next, we're going to be talking about our second special function. So this function is called the floor function. So you can think of it as like your literal floor. Basically, it takes a number. It can be a decimal, it can be anything, and it'll take the largest integer such that it doesn't exceed it. So 3 is just 3 because 3 is an integer, but 5.3, like it's in between 5 and 6. But because it's not quite at 6, we round down. You can think of it as rounding down, I guess. You round down to 5. So the floor of 5.3 is just 5. And similarly, if we take the floor of 1.487, because it's not 2, like it's closer to 1. And if we round down, we get 1. So that's what you can think of your floored function as. And here we have the opposite of the floored function. You can think of your ceiling. Yeah, so the opposite of the floor function, wow, you might guess it. So it's the ceiling function, which means that you always round up. So the ceiling of 3 is still 3 because 3 is an integer. But now, contrary to before, when we had the floor of 5.3 is 5, we have the ceiling of 5.3 is 6. And then similarly, the same number here, it wouldn't round down to 1, but it would round up to 2. So these are some cool functions, and now we're going to do some questions with them. So for this one, I think I can go over this one with you guys. Yes, so Let me annotate again because I wrote this wrong. So you can ignore this. This is otherwise. And this 3 line x, this is basically just if x is a multiple of 3. So like if x is like 3, 6, 9, and it shouldn't be x, it should be the floor of x because I can't type floors. 12. So yeah, if the floor of x, this is basically saying if the floor of x is a multiple of 3, then we increment x by 2. So let's say we have the floor of 3 here. The floor of 3 is 3, right? And 3 is a multiple of 3, so this is correct. So therefore, f of 3, because we know that the floor of 3 is a multiple of 3, f of 3 would just be 3 plus 2, which is just 5. Very nice. And now what this says is we have two statements here. This is kind of a new function that is introduced. And we have if it isn't, so otherwise basically means if whatever the floor of this number is not a multiple of 3, so it's not a multiple of 3, we decrease it by 1. So here, let's say we had the floor of, I don't know, 5.1. I can't type. 5.1. So that would just be 5 because we round down. And then the function of 5, because the floor of 5 was not a multiple of 3, f of 5 would just be 5 minus 1, which is 4. So that's like your intro to this question. And now what we're trying to find is we're trying to compute f of f of f of f of f of pi. Wow, who decided to put all these f's here? I wonder. And we know that pi is roughly, it's like 3 point, I wonder how many of you know like a lot of these digits. 3.1415 dot dot dot. It doesn't really matter because like it's you can just use 3.14, that's fine. So we're trying to compute f of f of f of f of f of pi. And I guess I'll give you guys like, or I don't know, maybe I'll just go through this one with you guys. And if you have any questions, we can go through them. So I will clear my drawings. All right, so how do we find this crazy thing, right? Like that's kind of crazy. So we're gonna start with finding the floor of pi, because what are we asking ourselves here? We're basically asking ourselves, is the floor of pi a multiple of 3? And if it is, then we plus 2. If it's not, we subtract 1. So the floor of pi is just 3 because pi is 3.141592 dot dot dot. And we know that 3 is divisible by 3. So that means we know that f of pi is just equal to pi plus 2. Because here we have it is divisible by 3, so we're going to increment it by 2. So we know f of pi is pi plus 2. So now we're going to find the second one. So we're going to find f of pi. So what do we know? We know that f of pi is pi plus 2 already. So f of pi is basically just the function of pi plus 2. So what do we do here? We do the same thing. Before we found the floor of pi, but now we need to find the floor of pi plus 2. So pi plus 2 is like 3.1415 dot 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 plus 2, which is like 5.5 and a bit. So we know the floor of it would just be 5 because we round down. And we know that 5 is not divisible by 3. So what do we do if something isn't divisible by 3? We subtract 1. So we have f of pi plus 2 is just pi plus 2 minus 1, and we get pi plus 1. And then we keep doing this, and it gets kind of repetitive. So this is what we had. We had that f of pi is pi plus 1. So we do the same thing, and then we find the floor of pi plus 1, and it's 4. And we're like, hey, it's not divisible by 3 again. Oh no. So that means we subtract 1. So if we subtract 1 again, we get pi plus 1 minus 1 is pi. Now here you might notice something, because we end with pi here, but what did we start with? Like we started with pi as well. So you can actually think of this as a cycle, because we have pi plus 2, pi plus 1, pi. So because of pi, we ended with pi, but we already know that f of pi is just pi plus 2. So we know that this is actually just a cycle. So it'll always go pi plus 2, pi plus 1, pi, pi plus 2, pi plus 1, pi. So therefore, because we want to find like 5 f's of x, we know that it's actually just pi plus 1 because it's the fifth one. So we have 1, 2, 3, 1, 2. So that is the fifth one. And that's how we would solve that question. All right, so now we have a few challenge questions because we still have a few minutes. So this was taken from 2011's AMC 10B, and it is question 19. So after learning all of those different lessons or components, you should be able to solve these questions. So we will give you a little time to do so.